the other one in the telephone, so I'm not going to look into the eyes of everyone, if you can excuse me for that. So just let me know, because I cannot see the screen. If just let me know when you would like to start.
Yeah.
If you're okay.
Okay. So now I put the code of conduct if you want.
No, if that's fine, I'll take it from here once if we have the presentation ready.
Yeah, it is ready.
Okay, good.
Everybody can see my screen. Bruno, you can see my presentation?
Yes.
Okay,
yes,
I can see it.
Yeah.
I can see your presentation.
Great.
Okay, so let's let everyone just join us in their own time, and let's begin, because it's already 3 minutes after 2 o'clock CET. Okay. Thank you. So I'll take it from here. Thank you very much for this Flo, for organizing this event, and good afternoon, everyone. Welcome to the EIA Summer Irrigation Forum in a very hot day today. My name is Moshe Bernstein. I'm president of the Irrigation Association, the European Irrigation Association, and I'm very pleased to welcome you today. Our forum today is dedicated to a quite different and important, I would say, interesting question, is hydroponics irrigation. It seems to be like a very... Yes, I'm sorry. I heard someone. Hello, everyone. Okay, so if you can just kindly mute your telephone, and we'll continue. Thank you. So the question is about the hydroponics today. It sounds very simple. It might, I would say, sound very simple at first glance, but it can open a broader discussion on how we define irrigation. How do we manage water in a modern growing systems? How do we connect what we know as a classical irrigation approach to the new agricultural and urban solutions we see more and more? So we have a full agenda today. Thank you for joining. I will keep it very short for the opening and very practical. So let's move to the next slide, please, Flo. Because before we begin, I always like to remind everyone the code of conduct, and also to go through a few housekeeping rules. So just to put everyone on the same page, as always, the EIA activities are being conducted in full compliance with applicable law, especially competition law, where all our discussions, no matter where and what, should remain professional. I would also say open and constructive. I would like to remind everyone that we must avoid any discussion on commercially sensitive information, anything about investment, turnover, information, production, tenders, whatever. We don't do this. The code of conduct applies for the members, but also applies to the participants taking part in the activities of the EIA, such as the forum today. Next, please. I don't see it. Yeah, yeah, thank you. A few practical points before we start. The session is being recorded, I think. Yeah. But it will be recorded now. Thank you. And it will be shared afterwards with everyone. Please make sure that your full name and organization are correctly displayed, so that everyone knows, and will know who's participating. Please keep your microphone muted. While you're not speaking, you're more than welcome to open it, of course, and to participate actively in the right moment in the discussion. And there will be such moments like this. And you're also very much welcome to use the chat box for any questions. We will try to collect questions to come back with these questions to the discussion during the session. And finally, as always, we like it very much that you turn on your cameras if this is okay with you. Nothing is obligatory, but it's always nicer when we can see each other, especially in online forums. Next, please. So let me now briefly present today's agenda. So first of all, we will start with a short introduction on some updates from the EIA. What's going on today, what's going to happen in the next month, and I will take the lead on this one. Then I'm going to invite Fleur Martin, communication officer, to introduce new members. I think we have 5 new members since last round. New members that just recently joined the association, they will be represented here and presented as well. After that, we'll move to the first invited speaker, Professor Dimitrios Savvas. Dimitrios Savvas is director of the Laboratory of Vegetables Crops at the Agricultural University of Athens. And Professor Savvas will speak about recent developments in soilless and hydroponic cultivation. And he will probably help us, and I'm sure we'll have a very fruitful discussion to address this question: is hydroponic irrigation, and what are the considerations? And as I already mentioned, that's a deep question also for the sector to be dealing with. The second presentation will be given from Baptiste Laurent, founding president of Vertuo. He will speak about the innovation technology. Within the framework of the innovation technology session, we talk about water-independent greening solutions for the cities. I think this will be the right moment later on to open the floor for discussions and Q&A, and the forum is planned to finish no later than 4 o'clock CE time. Looking forward for a very interesting forum today. Let's move on, please. Right. So I will take a few minutes just to share with you what is happening in the European Irrigation Association, what's cooking for what is planned for the next month. The first slide that I wanted to share with you is a short update on where we stand today. If you can please mute your microphones, it would be great. Thank you very much. Please mute your microphone. I'm not sure where this comes from. It will be much easier for everyone to answer. Flo, can you mute the microphones for everyone? And then I will open mine, or no? Okay. Thank you very much. That was now I say everything is okay. Can you hear me? I cannot hear you.
Yes.
But okay, thank you. Thanks for that. Okay, so what's happening in the association? I would say that the key message that I wanted to share with you today is that the association is no longer acting only as a traditional sector representative. We're gradually building a stronger role, I would say, as a platform that connects policy, market, and practical implementation. And I will explain. I think in the past, the message was often it was quite simple. Europe needs irrigation. We all talk about it. We are doing it on a daily basis. Today, the discussion is becoming more precise. It's about Europe needs practical solutions to deliver water, deliver efficiency, deliver solutions for climate resilience, sustainable water management. And it's different. And that's the reason why we begin with the narrative that is evolving. So first, the EIA is becoming a stronger advocacy platform for the sector. We recently worked on a policy narrative paper with the participation of many good professional people. Instead of saying simply that Europe needs irrigation, we position precision irrigation, digital water management, as well as reutilization of water as practical tools to implement the water resilience and practically to implement the principle of water efficiency first within the water resilience strategy. So this is the logic behind position paper that only this morning we just submitted the paper to the commissioners, and this is the logic behind the toolkit, the advocacy toolkit, and everything that we do in face of the commission representatives. Second point, we are strengthening the market intelligence. We bring more value to the members. We try to bring more value to the members, and according to the feedbacks, I think that we're doing fine. We're doing okay here. Last Friday, we launched the first event, I hope in many more to come, that links the European water trends, financing, and strategies into what seems to be a clear business tool to our members. Together with the ESCP, the Business School of Paris in Paris, the collaborated work with the EIA, we presented the members the first executive strategic system session. Responded to a very clear request from many members for more market intelligence. So we're trying to build this bank of ideas and strategies for the members to better deal with what's going on with the changes we see today in Europe. The discussion is becoming a business-oriented, where the growth will come from in our sector. Geographically, where the growth will come from in terms of technologies, the irrigation systems, how customers evolve, what do they need today, how do we prove value, how do we provide proper, transparent ROI in the cities, in the agriculture, within different kind of customers. Next session will be held in Brussels. Brussels, this will be in September. It's gonna be also online. We're aiming to directly assist irrigation companies to plan their operational work plans for the next year, for next years, in accordance with what we see as a rapidly changing Europe today. So stay tuned to this. I think this will be very interesting, and more business content will come into the discussion, and the success of discussion is the fruitful exchange that we have between members. Third, we're increasing strategic visibility. We've been invited more and more to wider water discussions. During the month of June, we participated in the water reuse Euromed in Madrid, the European Parliament Fruit Crew Roundtable last week in the EU Parliament. Next major event will be organized by the EIA, we call it the Irrigation Days, on the 28th and 29th in September in Brussels as well. And I think that all of these events meant to provide this platform that I've just mentioned to connect agriculture, urban landscape, research, companies, different technologies, and policymakers together. And the point is that the EIA is becoming a bridge between this policy, business reality, and deployment in the field or in the cities. What next? If you can please move to the next slide. So where are we going from here? Looking ahead, opportunities continue to be focused on helping members to anticipate the changes. Even today's summer forum is part of this effort. It allows us to explore emerging questions, such as the question today: hydroponics, irrigation, hydroponics, urban greening solutions. We're gonna discuss later. Many questions arises, and I think that that's a very good platform to try and discuss. What does it mean for us? In July, we're going to focus on the dialogue with the European Commission, especially around the irrigation sector, irrigation association narrative about how irrigation contribute to water resilience and agricultural implementation. We're going to organize this Irrigation Days event in September. I think this will be a key moment for us because we will really connect strategy, policy, and implementations in the heart of where decisions are being taken in Brussels. Then looking forward on 2027 planning, we want to help members to translate these insights into real company level thinking with more market analysis, with more tools to deal with understanding what's going on around us, and more partnerships and investment priorities, where the monies come from, and how do we deal with the involvement of this sector. And the last but not least, I think that what we're trying to build is if I try to pack everything together, is a recurring source of sector intelligence or market observatory, evidence-based advocacy, to work more and more on building these tools. Because if I'm trying to conclude everything that we're trying to do, we try to provide to our members as a value, I would say I would use three words which are important: the narrative, the evidence, and the deployment. And the narrative is that irrigation should be seen as water resilience infrastructure. It's not only water consumption. It's about what we deliver using the right irrigation, the precision irrigation, which means many, many things. Precision irrigation. The second part is about the evidence. Everything needs to be measurable. It's about KPIs. It's about proof of concept and then proof of value. It's about building and proving the right ROI models in the market. What are the measurable outcomes? What we deliver as technology and system. And the third part is the deployment, and it's about turning everything that we just mentioned into practical adoption. It's on the ground work, and we do it through partnerships. We do it through funding eligibility. We can do it through a certification, that there is a team working on certification today, with practical implementation in the field and in the urban areas. So that is exactly where I believe the EIA can create value for members and can create value for the sector. So I'd just like to conclude by saying thanking all the people that are involved in the irrigation sector and irrigation association. Within these activities, we couldn't do it without you, that's for sure. I hope more and more professionals will join us to strengthen what we can deliver and to deepen the discussions we're having. And by that, I hope that the irrigation sector will help Europe to solve one of its most critical challenges today. So that's all about the irrigation association, what's going on, what's planned. And before moving to the main theme of today's forum, I would like to invite you, Fleur, to introduce the new members that just joined the association since the last forum. Thank you. You're on mute. At least I cannot hear you. Please go ahead. Yeah.
Yeah, thank you, Moshe, for this introduction. So, as we do at every forum, the new members who have recently joined us have the opportunity to introduce themselves for a few minutes. We are delighted to announce that 5 members have joined us since our last forum in April. And today, the EIA have 83 members. Among these 5 numbers, 3 of them took the opportunity to presented by this forum to introduce themselves today. So the first company is Moteur Baudouin, and it's Lorraine Ducrop who is going to do the presentation, if she's here.
Yes, I'm here, and thank you for the opportunity to present Baudouin. So hi, everybody. My name is Laurine, and I'm in charge of the marketing for Moteur Baudouin. So first of all, let me introduce Baudouin. Baudouin, we are historically recognized for marine engines that we are manufacturing into our factory in Cassis. We have been founded in 1918, so we have more than a century of industrial experience. And throughout the years, we have been started to expand our expertise into power generation, critical power application, and data centers, where reliability and continuity of service are essential. And today, we bring exactly the same culture of reliability to land-based applications, including agriculture, irrigation, and water pumping. Reason why I'm here today, and reason why we have decided to be partner of the Irrigation Association. Can we go to slide 2, please?
Yeah.
So for irrigation applications, the engine is not just a component, it is part of a critical system that must work when water is needed. And this is why Baudouin combines industrial scale, competitive lead times, and a global service network. We have more than 100 service partners worldwide, and it means that we can support customers not only at delivery, but also during commissioning, maintenance, and long-term operation, which is something critical for your all applications and works. If we go to the slide 3, we will be able to show you the domain that we are working with, demanding application that we call off-highway, which means that we are specialized into agriculture, irrigation, and water pumping. And these applications require engines that are robust first, of course, because they are in harsh environments, but also easy to maintain and able to operate in demanding field conditions. And sometimes with, of course, long-running hours, dust, heat, and variable fuel quality. And this is where we can answer to all these specific applications. Finally, if we go a little bit further on the slide 4, and it's a really brief nutshell of what we are doing at Baudouin. We have a complete range of variable speed engines that helps water management systems for irrigations, but also for pumping. Of course, we are answering to all the major certifications that are needed, especially in Europe with the stage 5. And so in short, I would say that we offer scalable and easy to service engines to support water availability, operational continuity, and field performance. So to conclude, Baudouin off-highway is about reliability, flexibility, and practical efficiency. And of course, we have a common goal, let's say, for irrigation. It's to provide power solutions that help customers to keep water moving and reduce downtime and operate with confidence. Thank you.
Thank you, Maureen.
Welcome, Maureen. Thank you.
Maureen,
Thank you.
thank you. So the next new member is EIA Verde, and they join us as premium member. So it is great news. And so I will ask Rawad El Rabba if he's here to do the presentation.
Thank you, Fleur. Good afternoon, everyone. My name is Rawad El Rabba, and I am the National Water Lead for EIA Verde France. For those who may not know EIA Verde, we are Europe's leading company in landscape and green infrastructure. We currently operate in 7 countries because we expanded lately to Spain. Can we move to the next, please, to the next slide? And France is our largest market with agencies located across the entire country. Our mission is to bring nature into living environments while addressing major environmental challenges such as climate adaptation, biodiversity enhancement, and water conservation. Well, at EIA Verde, I develop and strengthen our water-related activities across France, including irrigation, pumping systems, fountains, misting systems, rainwater harvesting and reuse, and innovative blue-green infrastructure solutions. With EIA Verde, water is a strategic field of expertise. Please, Fleur, can we move to the next, please?
Yeah.
And we design and install. So we have engineers and installers. We design and install and maintain irrigation systems for parks, sports fields, urban landscapes, and green infrastructure projects. We also deploy smart irrigation solutions based on weather data, centralized control systems, and IoT technologies to improve water efficiency. And today, much of our work is dedicated to helping public and private clients to mainly find alternative water sources and implement integrated water management solutions to reduce pressure on potable water and improve water resilience. Well, we decided to join EIA because it's very important for us as I look forward to exchanging ideas and expertise with all of you. I believe irrigation professionals have a key role to play in addressing future water challenges, because irrigation now is often seen as water consumption rather than a precise technical tool to deliver the right amount of water in the right place and at the right time. And at EIA Verde, we believe the future of landscaping depends not only on plants, but also on how intelligently we manage water, because it's becoming one of the most critical challenges for urban landscape. Well, thank you very much for listening, and I look forward to today's forum. Thank you.
Thank you. Thank you,
Howard.
and welcome. So the third new member is rain dancer, and I will ask Frank Dunelt to do the presentation if he's in the meeting.
Thank you. My name is Frank Dunelt. I'm CEO and founder of Rain Dancer, and thank you for having the possibility to introduce the company here at this place. Rain Dancer is a digital solution for irrigation management that is based in Berlin, in Germany. And our product was first introduced more than 10 years ago, 2014, and it has been an incredible journey. Let's say now with thousands and thousands of users, and we are now operating in more than 40 countries in Europe and also overseas. So that's quite amazing. Can you go to the next slide?
Yeah.
When we talk about irrigation, we mainly talk about this kind of irrigation machines. Raindancer is, we can say, by far the world-leading solution for hose reel management in all his variants, but it also supports pivot and linear systems. So we have all these systems in one solution, and the best of it is that it is brand independent and can be retrofitted on all these brands and all also very old irrigation machines. And that way we think we can have a huge impact in making even the old equipment smart and more efficient. Next slide, please. The core of the product is helping the farmers to make their life easier while having all information at a glance right in their pocket. So they see what happens on the farm, they get notifications in case of a fault, they can operate their machines by remote control. And so that's all, let's say, about saving water. They save energy, but mainly time to manage that. Next slide, please. But it's not just the monitoring part. We consider Raindancer as a platform where everything about irrigation comes together in one app. And so there's also the pump control where the water needs to come from something, and we optimize pressure and energy usage on the pump side. Machines and the pumps can talk to each other. There's also a very important product, that's the gun sector control. That sector control adjusts the angle of the irrigated area on gun machines by GPS, and that avoids wasting of water outside the field. And also difficult areas will have a bit better application rate, and so we can maximize the yields for the farmer, which is always a good argument to buy this product. We also introduced variable rate irrigation for hose reel machines, and that also brand independent. And of course, there's all this data can be used for advanced reportings. But it doesn't stop like with these main products. We have several tools for collaboration, automation, and also integration. And integration means that we are open to deliver data for third-party consumers, for example. That can be farm management software systems. Several are using this data already. We also integrate, for example, sensors or weather stations to make all these information available in our platform, so that farmers don't have to open 5 apps a day for this information. And also third-party services that can be irrigation advisory software or tools that can generate application maps for the irrigation. And so in the end, all these things come together in Raindancer. And so we think that is really a step forward to make these classic irrigation machines more efficient, and so this type of machines approach finally 2026 and not 1980 anymore.
Thank
Thank
you.
you.
Thank you.
Thank you. Welcome.
Welcome. Okay, so thank you for this presentation. And this is our premium members. We are very proud to say that today we have 14 premium members. And our members. So if you attend this forum and you would like to join the association as a member, you can register directly on our website. Or if you need more information about joining us, you can email me to communication@irrigationeurope.eu.
Thank you, Fleur.
Thank you. So, so now we will move to the second part of this forum with our invited speaker, Dimitrios Savvas from the Agricultural University of Athens. He will explore whether hydroponics fits within traditional irrigation definition and what this means for the future of water management in agriculture. So I think, Dimitrios, are you here?
Yes, can you hear me?
Yeah, of course. I think you want to show your presentation. That's it?
Not so important. If you, I see that you have already uploaded the presentation. So if you can change this every time that I say next slide, it's okay for me.
Okay. Okay, perfect. Let's do that.
Okay. Good. Good afternoon, everybody. I am Dimitrios Savvas, a professor at the Agricultural University of Athens, and I'm specialized in hydroponics. I work on hydroponics since 1988, actually, so almost 40 years now. The topic of my presentation is recent developments in soilless hydroponic cultivation. Next slide, please. Okay. Hydroponics is also known as soilless culture and includes all methods of growing plants with their roots growing out of the natural soil and fed exclusively through the supply of a complete nutrient solution. The roots grow either directly in pure nutrient solution or in porous growing media that are also known as substrates, which retain nutrient solution in part of the pores, the substrate pores. Here I wanted to provide some additional information about this. It's not full consensus about the terms hydroponics and soilless culture. Some scientists use this as synonyms, but there are other scientists who make a distinction, and they think that hydroponics includes only systems where only nutrient solution is used without any aggregate. And there is a moderate approach, which is in between, which says, okay, hydroponics is the cultivation of the plants either directly in nutrient solution without any aggregate, or in aggregates, substrates, growing media that are chemically inert, which means that they do not exchange nutrient ions with the nutrient solution. It's up to you to, you will find in the literature all the terms, so it makes no sense to say what is most preferably. I think that most practical is to use these terms interchangeably and more or less as synonyms. And as already mentioned, there are soilless culture systems on substrates, growing media like rock wool or pumice or perlite, and there are also hydroponic systems with only nutrient solution like the NFT system and aeroponics. And also floating systems, which are very common actually for leafy vegetables. Next slide, please. So the common characteristic of all the systems is that the nutrition of the plants and also the water demands of the plants are covered by supplying a nutrient solution. So by supplying a nutrient solution, we speak about fertigation. In all cases, we have fertigation, fertilization plus irrigation at the same time. And this is a common trend actually nowadays, especially in horticulture. The nutrition of the plants takes place through the irrigation water by supplying a nutrient solution instead of just water. In the nutrient solution, all nutrients are diluted in this, and since the plants are fed exclusively with inorganic nutrients, this is, I hope that this is clear, the plants do not need any organic substances, they only need inorganic substances. So there is an exception, iron, but this is not a real exception because iron has to be supplied in organic form as chelate, iron chelate, just because this maintains iron water soluble. Otherwise, iron will precipitate together with the phosphate because it is the iron phosphate has a very, very low solubility. Next slide, please. So here are the nutrients that are essential for the plants and must be supplied with the nutrient solution. They are 12 nutrients. Of course, in addition is hydrogen and oxygen, which are constituents of the water, that are also in the nutrient solution included. And then there is also another nutrient is carbon, but carbon is absorbed via photosynthesis, via the leaves. So it is not supplied via the nutrient solution. And also chloride, but chloride is needed at very, very small amounts, and it is always available in the water. So no special care about the supply of chloride. Of the 12 nutrients that plants need for their nutrition, 6 of them are supplied at higher concentrations, and they are the micronutrients, and then the remaining 6, iron, manganese, zinc, copper, boron, and molybdenum, they are supplied in much smaller concentrations at the micromole level, and they are termed micronutrients. It is important to supply the nutrients in the correct form, and the forms of supply are shown here. Just a very typical example, for instance, nitrogen. And nitrogen is part of the air. 80% of the air is nitrogen, and still the plants cannot take up this nitrogen, and we have to supply the nitrogen via the roots, via the soil or the soilless medium. The plants take up only nitrates and ammonium, so we have to supply nitrogen in these two forms. And phosphorus here as bihydrogen phosphate, sulfates, potassium, calcium, and magnesium ions. Next slide, please. Okay, the preparation of nutrient solution requires the use of special fertigation machines like this one here. You see on the left such a system, and on the right you see a drawing of this, a schematic representation. Normally there is a mixing tank, and in this mixing tank the water coming inside is mixed with the nutrients. The nutrients are in concentrated solutions, and so actually the concentrated solutions are mixed with water at specific ratios. The standard ratio is 1 to 100, but this can change depending on the EC and the pH, the target PC and the target pH in the nutrient solution that goes out to the plants. Actually, using a fertigation machine, we irrigate at the same time the plant. So the fertigation machine normally includes also an irrigation scheduling compartment, which means it is important not only to prepare the nutrient solution, but to use only a fertigation, fertigation programming system to adjust the first the frequency, and second also the irrigation rate, the duration of each irrigation event, and frequency of irrigation supply. So this is very important and part of a fertigation system. Next slide, please. Unfortunately, it has been spread out here, but anyway, it's still possible to read it. Okay, now the question is hydroponics irrigation. Irrigation is intimately associated with nutrition in soilless culture, as the nutrient solution is intended to cover the plant needs in both nutrients and water. So hydroponics is not irrigation, but is related very closely to irrigation, because irrigation is the means of supplying water and nutrients to the plants. In some water culture systems like floating or NFT, the roots of the plants grow directly in a nutrient solution, so there is no need for regular supply of nutrient solution, and here there is no need for any irrigation scheduling. But generally, in hydroponics, we need always with this exception, to apply an irrigation scheduling. In soilless cultivations on substrates like rock wool or perlite, but also in NFT and aeroponics, the plants are frequently irrigated. In the soil, normally we irrigate once per day or every 2-3 days. In soilless culture systems, in hydroponics, we irrigate many times during one day, smaller amount of nutrient solution of water, but much more frequently. The total amount of nutrient solution of water that we have to supply to the plants is more or less similar, because the plant needs are always the same, more or less. That means 10, 15, up to 20, perhaps, irrigation events per day. And the duration of each irrigation event is from 2 to 6 minutes maximum. And to do that, we need, as already mentioned, an irrigation controller, which is integrated to the fertigation machines. And all the system is aims actually at activating solenoid valves, which allow for the supply of nutrient solution for the target duration, actually. So here there are two decisions that have to be taken with respect to the irrigation. The first one is how long we irrigate, duration of its irrigation, and how frequently we irrigate. Next slide, please. Okay. Just here to show you some data indicating that the water consumption by plants via fertigation, via transpiration, is more intensive during the midday and much less at the morning or in the afternoon. And there is also some consumption during the night. So the irrigation scheduling during the day has to be scheduled following this concept, which means much more frequently frequent irrigation even during the midday and less in the morning and in the afternoon. But the question is, okay, how we adjust this? One approach is to irrigate at predetermined times. That means we in the controlling system, we fix the times of irrigation. This system is inefficient because the plant needs to may be different, fully different during different days because of the climatic conditions. Some days are very sunny, other days are cloudy, and so on. So either we have to change this schedule every day and still we don't know exactly what happens, or we have a standard, which means that sometimes the irrigation is more than the plant needs and sometimes less, which is that's why this is not a suggested system, although it is used by many growers. Next slide, please. Then irrigation based on simulation or measurement of the evapotranspiration. We can use here various models to estimate the evapotranspiration. I just show here something which is very common from Baye. Here this equation that has been suggested, but there are perhaps modification of that, and this is something that you know very well. Anyway, the point here is that we have to predict the irrigation for short times, because not for some days, but just for short periods of the day, for 1 or 2 hours. So it must be much more accurate. And in the greenhouse, because hydroponics takes place in greenhouse, we have to take into consideration the shading by the greenhouse, the differences in the climatic conditions, which have a strong impact on the water requirements of the crop. Next slide, please. Another approach is to measure the transpiration, and this can be achieved by measuring the weight differences at the short term using special ways. Here, this is an experimental approach, but there are commercial systems that they do that today, because if such a system loses water, loses some weight, the weight difference at short intervals is just because of the loss of water via transpiration. No other reason, no other factor can change the weight of the plants and the substrate in a short period. So based on this, we can quantitatively estimate the water consumption, and whenever a particular amount of water has been consumed, we can apply again a new irrigation event. Next slide, please. Okay, and another important topic now is the management of nutrition, because as already mentioned, in soilless culture, we apply fertigation, which means the one question is how we manage the frequency and the duration of irrigation. The other point is what is the composition of the nutrient solution and how we have to change this to meet the plant requirements. Next slide, please. Next. Okay. One could say, okay, why not just have a recipe and say that and that amount of each nutrient can be supplied. One point is that the that the nutrients are not alone. Always we have the nutrients in pairs because they are mostly salts. Potassium nitrate, potassium phosphate, potassium sulfate, and so on. So we have, whenever we supply one nutrient, at the same time we supply another one. So we have to take into consideration this complexity. But still, this could be overcome. We can calculate a recipe and say this amount of potassium nitrate, this amount of calcium sulfate, and so on, has to be applied at this amount of water, and we have a nutrient solution for tomato, then another one for cucumber, and so on. But still, then there is another complication. Next slide, please. And this is the composition of the water. The water itself has already some nutrients. And the nutrients that are included in the water are calcium, magnesium, and sulfates. The concentrations can vary. In some water sources, the concentrations are small, but in many other water sources, the concentrations are fairly high, and in some cases, they can even exceed the plant requirements. We have also such cases. Also, some micronutrients can be present: manganese, zinc, copper, boron, chloride, and also other macroelements that are not considered plant nutrients. For instance, bicarbonates, which are very important as they are related to the pH of the water, and also sodium, which is related to the salinity problems. So we need to take all this into consideration to calculate a nutrient solution recipe for a crop. So we cannot have a recipe, a universal recipe for all plants. We have to calculate the fertilizers needed to prepare a nutrient solution individually for each grower. Next slide, please. And in addition to this, we need to take into consideration that the plant requirements may change depending on the cropping stage. The plant requirements are different when the plant is at the vegetative stage, for instance, tomato or cucumber or whatever, and different when the plants start producing fruit. Also even for lettuce, the plant requirements are fully different at the beginning than at the later cropping stage. So we have to take also this into consideration, and also the season of the year, because different seasons of the years we have fully different climatic conditions, which means different transpiration rates, and this is important for the concentrations that we have to supply. This is a fairly complex issue. The time is too short to explain this in more detail. Anyway, these problems can be overcome by using decision support systems. The decision support systems are tools, digital tools, that they allow us to enter specific information to this, and then we obtain as an output a full recipe adapted to the particular crop, the particular stage of the crop, the particular season of the year, and so on. And still, the plant requirements are not fully predictable. So even if we know the season of the year, that does not mean that we know exactly the plant requirements at this stage of cropping stage. So what we are doing here, we have to regularly take samples of the nutrient solution that is in the root environment and measure the nutrient concentrations. And based on these measurements, we can readjust the composition of the supplied nutrient solution. Next slide, please. At the Agricultural University of Athens, recognizing this necessity, we have developed a particular decision support system, which is named NutriSense, and here the website. This was supported mainly by a European research project, a Horizon project, a Conutri, which was just terminated end of April 2026, sorry. Next slide, please. Okay, here the website of Econutri. Our Econutri included 30 partners from Europe and China, and the Agricultural University of Athens was the coordinator of this project. But my team focused mainly on the closed loop soilless culture system, since this is our specialization. Why closed loop, and what does it mean when we say closed loop? Next slide, please. Closed loop means that the drainage, the effluents of the fertigation are collected and recycled. This is highly desired because the effluents that drain out of the root environment are normally at about 1/3 of the total supply, about 30%. And in addition to the waste of fertilizers and water, they result also in pollution of water resources, nitrate pollution of the groundwater, and also eutrophication because of nitrates and phosphorus runoff. So that's why the EU strongly supports the closed loop hydroponic systems with recycling, full recycling of the effluents. Especially in the Netherlands, it is now compulsory to apply closed loop systems. In other countries, it's not compulsory, and still many growers grow in open systems, but the trend is to switch over to closed systems in the future. And here you see the standard approach for two approaches, actually. This is for substrate systems on the left, and on the right for water culture systems. That means without substrate. As you see, in substrate-based systems, the drainage solution is mixed with water with a special mixer which can adjust the electric conductivity of the outgoing mixed solution. Then this solution passes through a fertigation machine, as I told you, and then in this way the new nutrients are added And the final solution that comes out, the outgoing solution, which is the supply solution, is applied to the crop. Then from the crop, we have again drainage, and the drainage is collected and returns back here to be recycled. So we have a full cycle. That's why these systems are termed closed systems. They are circular systems. And more or less the same also in water culture systems. The difference is that here we do not have a mixing device like this one here. The drainage comes normally into a reservoir. It is water comes also here to maintain a standard level of the mix. And then this mix of water and drainage comes through the fertigation system, and then it is applied again to the crop. This is the principle. Of course, there are many details that I cannot report in detail now. Next slide, please. Okay, why still many growers prefer to grow in open systems, although in closed systems they could save nutrients, fertilizers, and water. Why? One point is that recycling of the nutrient solution may result in recycling of pathogens. This is addressed today by using special equipment to disinfect the drainage solution, to treat the drainage solution before reusing. And these are mainly UV filters, but there are also some other technologies like sand filters, ultrafiltration anyway. But the most common is UV radiation. The second, anyway, for this there is already existing technology. The second problem is the composition of the nutrient solution changes as it passes through the root environment. So the drainage has a different composition than the supply. So we cannot just reuse it as it is, but we have to take into consideration its new composition and replenish the nutrients at the quantities needed in each case. So this complicates the fertigation, the calculation of the fertigation of the system. And a third point is that sodium originating from the water, because many water sources have substantial amounts of sodium. The sodium can accumulate in open systems. By rejecting the effluents, we reject also sodium, so there is a leaching of sodium, to say. So the problems of salinity are much less than in closed systems. Of course, if we have good quality water with a very low sodium concentration, this is not a problem. Next slide, please. So just to show here very quickly, of course, the time is very pressing. What happens with the sodium accumulation? In an experiment with cucumber, we tested 4 levels of sodium concentration in the water, 0.8, 4, 8, and 12. And with 0.8, as you see, the accumulation reached a level of about 12, which is still okay for the plants. But even in this case, we reached the level of 12. With 4 millimoles sodium chloride in the water, in the pure water, in the raw water, the concentration of sodium due to recycling, due to accumulation in the recycling, was about 35, and even more when we have 8 and 12. So if the concentration of sodium in the water is more than, let's say, 2-3 millimoles, depending on the crop species, we need to desaline the water. Otherwise, it's not possible to apply a fully closed system with full recycling of the drainage solution. Can we move to the next, please? Okay. Anyway, to make it easier for the growers to switch over to closed systems, in my laboratory, we have developed some novel algorithms which are applied via the decision support system NutriSense that I have shown already before, to optimize the nutrition in closed loop soilless cropping systems, taking into consideration several parameters. I do not have time now to explain this in detail. Anyway, these algorithms were applied when we use good quality water without sodium accumulation. Next slide, please. But okay, what is the state of the art with the management of nutrients of the nutrition in closed loop hydroponic systems? Currently, every 2 weeks, the growers send samples to the laboratories, to a chemical laboratory, and then they receive the results of the analysis, which takes about 3-4 days at least. And then, based on this analysis, they change the recipe. But what is the problem in here? The problem is that when the grower receives back the results from the laboratory, it is 3, 4, 5 days after the collection of the sample, which means that it is not anymore actual. Normally the growers use 2 stock solutions, A and B, and they change the composition of these stock solutions every 2 weeks or every 3 weeks in some cases, depending. So this is not very efficient. Still, it is possible to use, and that's why many growers still successfully can supply closed systems, but with some difficulty. So we try it in my laboratory and within the EcoNutri project, not my laboratory, because we had cooperation with the University of Almeria and also with Wageningen University about this. We developed special algorithms for this. Next slide, please. And also we use ion selective electrodes to measure the concentrations of the nutrients in situ in the greenhouse, which means that we don't need to send the sample to the laboratory and receive the results after 3 or 4 or 5 days. But on the same day that we take the sample, we make the measurements. It takes 10 minutes manually. And then we introduce these values to a decision support system like NutriSense, and then we obtain the new recipe back. And if, okay, this is the main innovation, the use of ion selective electrodes, but always it is important to have the right software for this, because if we have the measurements and we do not have a suitable software, it's not so useful to measure every day. Okay, next slide, please. So the most successful approach up to now was the use of this type of electrodes. They can measure 4 nutrients, actually 3 nutrients, and sodium, nitrates, calcium, and potassium, and also sodium. And by introducing this daily, this can be performed daily. It takes not more than 10 minutes. And if we don't wish to do that daily, every 2 days, every 3 days, it's up to the grower. But daily, it's very easy if we wish to have perfect nutrition of the plants. And then we introduce this data to the system, and we obtain the new recipe that can be applied easily by using a new innovation. Can we go to the next slide, please? So, okay, just to show you here some results indicating that using this system, we could very accurately maintain the nitrate concentration in the drainage solution in the root environment, actually, close to the target. The target is the dot line here. And here we compare the EIA means ion selective electrodes. So the red line is the use of ion selective electrodes. The blue line is the standard system. And you see that with the ion selective electrodes, by measuring every day, we could maintain the nitrate concentration very close to the target, whereas with the traditional system with measuring and sending to the laboratory every 2 weeks, there is a much larger fluctuation. And we had also yield benefits with that. Okay, this is just a typical example with nitrates, the same also with potassium and calcium and other nutrients. Okay, next slide, please. But to achieve this, we have moved forward from the traditional A and B system. That means stock solution A and stock solution B of fertilizers, concentrated solution A and concentrated solution B. We switched over to a more advanced system with 8 stock solutions of fertilizers. In each concentrated solutions. When I say stock solutions, they are concentrated solutions. In each tank contains one specific fertilizer. For instance, here calcium nitrate, here potassium nitrate, here magnesium sulfate, here potassium dihydrogen phosphate, here iron chelate, and so on. So we need normally 9 tanks with individual fertilizers, 8 salts and 1 acid to adjust the pH. So this is an innovation that will be in the near future will be adopted. We expect that will be adopted by many growers because it makes much easier the readjustment of the nutrition. We can do that every day. We can change the composition of the nutrient solution every day without any need to change completely the two stock solutions. In the traditional system, we can only when the two stock solutions A and B are consumed, then we can prepare new, and this new one can be different in composition. With this system, we don't need to change the stock solution composition. We just need to readjust the injection rate of each fertilizer, which is much more convenient and can be automatically prepared via a suitable DSS like NutriSense. Next slide, please. And in that model, let's say, and that approach, in that strategy, we added also a special strategy to control also the sodium accumulation if the sodium concentration in the water is suboptimal, up to, let's say, 3 millimoles per liter. If it is higher, there is no possibility to adjust this only via the digital tools and DSS. You have to use desalination systems. Okay, next slide, please. Just to show you what is the approach here, the strategy. The strategy is as follows. If we have such a concentration in the water, let's say 3 million, in our experiment, it was a cucumber experiment, it was 2.5. And with 2.5 in the water, the sodium concentration gradually increased up to 12. At 12, there was leveling up. There was no further accumulation because the input of 2.5 millimoles of sodium was equal to the removal via the plant uptake. So the plant was forced to take up 2.5 at this situation. So there was an equilibrium here. The same with chlorides. This increase of the sodium and chloride in the nutrient solution did not result in an increase in the EC, as you see here. I speak about the closed system with condensation using the ion selective electrodes and NutriSense. As you see, the green line, as you see, the EC was similar to the open system. The open system was the blue line, which is 1. Here, as you see, in open system, there was no accumulation of sodium and chloride. So despite the sodium and chloride accumulation, the EC did not increase, so we did not have any salinity problems here. Why? Because the increase of sodium and chloride was compensated for by decreasing the macronutrients, potassium, calcium, nitrates, also magnesium that is not shown here. So in this way, any increase of sodium and chloride was compensated for by decreases of potassium, calcium, and nitrates. This is possible up to a certain level. We cannot go below these levels because if we go below these levels, then we risk the nutrition of the plant. That's why I say that we cannot compensate more than 2.5 millimoles of sodium. Anyway, using this software, it is very, it is easy and and we can accurately control salinity problems in soilless cropping systems. If the concentration of sodium in the water, I will repeat it, is not more than 2.5 to 3 millimoles per liter maximum. Otherwise, we have either to use a desalination system, reverse osmosis, or to make the system semi-closed, which means that part of the drainage should be rejected. But also this is controlled by a suitable DSS like NutriSense. It calculates accurately the amount of discharge, so we do not waste all the drainage. Part of the drainage is reused and part of the drainage is rejected if the concentration of sodium is more than 2.5. Next slide, please. One problem that we still noticed and still is not fully addressed is the accuracy of the electrodes, not the electrodes I showed you. I forgot to tell you that the next step is to use the electrodes online. There are other electrodes in the market that they can operate online, which means that we don't need to measure manually every day. They are on the system, they measure, they send the data to NutriSense or any other similar DSS, and then the DSS communicates, is connected online via the fertigation machine and applies the irrigation. This is a very nice concept, can fully automate the whole system. The only weak point at the moment is the accuracy of the electrodes. We have worked with OptiSense electrodes, but there are no other that are more accurate at the moment. And to improve their accuracy, we are now working with machine learning and AI approaches. A PhD student of me is working on this, who is very good in computer sciences. I'm not so good in computers. I'm an agronomist. And the approach is to measure, send the data okay, let's go to the next because it's not shown here. Here it's on the general approach, but in between of the ion selective electrodes and the DSS, the approach is now that we have another software which is based on AI-driven fertigation approaches using machine learning can calculate first, or not calculate, can correct actually the measurements based on previous measurements, and it has to be calibrated, of course. And also it can also adjust the irrigation plan. This is also important. So there are two tasks that have to be provided by this software based on machine learning. Next slide, please. Okay, and currently we have terminated an experiment. Here we have this fully innovative fertigation system with 8+1 tanks of fertigation solutions, concentrated solutions. Here are the ion selective electrodes, and the whole system works on this concept. And now we are working, trying through machine learning to optimize the accuracy of the measurements, because this is at the moment let's say the weak point of the system. The accuracy of the measurements via the ion selective electrodes, if they are working online. If they are working offline, it's much better and they can be used even in commercial applications. But online, still it is at experimental level. We have to improve the accuracy of the measurements. And this is a PhD study, as I told you, and we will continue now in September with the next experiment. Okay, and the next slide, I think is the last one. Okay, thank you for your attention. This was the presentation. Okay, it took a little bit longer time. Sorry for that, but I think it was something interesting. I hope at least that it was interesting for you.
Thank you. Thank you.
I'm available for any questions.
Yeah, normally there is a Q&A session now. So if you have in the audience, if someone have a question or a remark or comment, please go ahead.
Maybe there are questions in the chat I cannot see. But...
Yeah, may I address a question? Thank you, Dimitrios. Very interesting and very informative, as I was telling. I discovered a lot. I was used to work in the field and not very sensitive to what happened in the greenhouses, but it's really interesting. One question, I am not, and probably I'm not the only one. What is the surface area that we have in Europe in terms of greenhouses, and what is the proportion of vegetables, for example, which is produced in this type of in this kind of situation? Yeah, technical solution.
Okay, the total area of greenhouses, you mean? I cannot recall now the exact number, but just indicatively, in Almeria, for instance, only in Almeria, it is about 40,000 hectares. Only in Almeria. There is a small area, of course, in Italy. In Greece, it's about 5,000. No, now it's about 6,000. Not so much. I have the numbers, but I cannot recall the exact number now. Anyway, there are also in the Netherlands, for instance, it's about 10,000 hectares, and about 25 to 30,000 is in Belgium. In France, I think it's a similar number.
Yep.
Okay, and what proportion of production do they represent? You have an idea or not?
I can tell you that in the greenhouse, we can achieve yields that they can be up to 10 times more than in an open field crop. But just have in mind that when we have a field, for instance, tomato, and tomato is grown in open field only in Mediterranean countries, because in the North European conditions, it makes no sense to grow in open field. In an open field, we can have about production for about 3-4 months, the maximum. That means the production in open field starts end of June, not earlier, mid of June, perhaps in very southern parts of Europe, and harvesting can go until end of September, sometimes also part of October. But due to the disease pressure, it's very difficult for the growers to harvest for all this period. So finally, the harvesting period is 3 months, about 3 months. In a greenhouse, we can harvest in 9 months, 3 times more. It's not only because we have more production, but also because we have a much longer production, because we can grow year round, 11 months cultivation, of which 2 months is the vegetative stage of the plant. There is no production, and then we start harvesting for 9 months. So that's why we have this high production. We can reach production of about 80 kilograms per square meter. And in open field, the production cannot be more than 8. So 8 to 80, just to.
Okay. Thank you.
Thank you. Moshi?
Yeah, just first of all, thank you very much, Professor Savvas, for this very insightful presentation. I appreciate it. I learned a lot, for sure. And I'm trying to take this to the implementation part. So this is the Association of Irrigation. And I think that the 2 points here, which quite I learned very interesting insights. First of all, it's about the efficiency of the irrigation, because we keep on talking about efficiency all the time. We're talking about water saving, closed loops. We're talking about better control, evaporation reduction, and so on and so forth. There are many aspects, and I wonder maybe how you see it today. This method, this technology is specialized only for controlled environment production in many places. If you look on the wider aspect of irrigation, do you think that the hydroponics will become more mainstream in Europe agriculture? How do you see this? Do you see that there are opportunities here for irrigation?
I think that hydroponics will remain production system for greenhouse, vegetables and cut flowers, and perhaps even some fruit now, because there is an interest also in growing fruit trees in greenhouses to produce earlier for early production, or some perhaps even out of the season in some places. But it will remain a technology mainly for greenhouse production. But on the other hand, greenhouse production is increasingly important because of the climate change, due to the extreme
Agree. Yeah.
yes, extreme weather conditions that may be faced. Protected cultivation is more effective. For instance, in Greece, and not only Greece, in other Mediterranean countries as well, in the last years, the production of tomato in greenhouses has massively increased, and in the open field has decreased because of the disease pressure. We have now tuta absoluta in open field, which is very difficult to control. We have also virus like the brown rugose. I don't know if you are informed about this. So more and more growers abandon the cultivation in open field and they move to greenhouse, or they adopt another crop, not tomato, for instance.
Great, thank you. Thank you very much for this. Okay, Florette, I don't know if there are more questions, but I think that we need to move to the
I think there is one question in the chat.
So maybe the last one, and then we move to Baptiste.
So it's do you have yield comparisons, standard production and fertigation, and precision production and fertigation?
Okay, I presented some papers in this presentation, and in these papers there are also yield comparisons, indicating that these systems with closed loop approaches are equally effective with open systems without yield losses, if this is the question. But generally, we know also that soilless cropping systems, generally now, they normally produce about 30% more than a cultivation in the soil, because in the greenhouse, many growers still grow in the soil, especially in Mediterranean countries. The general trend is that the high-tech greenhouses always grow soilless, hydroponics. The more, let's say, more primitive greenhouses, low-tech greenhouses, they still grow in the soil. And in that case, the yields are much lower because also the climate control is not efficient and there are many other problems with diseases and so on. Generally, soilless culture allows for full control of the crop and provides much higher yields.
Okay. Thank you.
I'd like to thank you for this session with Professor Savvas. It was very interesting. Unfortunately, we need to stop with the questions now because we need to move to the second speaker. So please stay with us, and thank you again for a very insightful presentation. Thank you for this.
Thank you too also for the invitation. It was a great pleasure for me to be here with you and present something about my specialization that I love very much, actually.
Yeah, we're on steady now. Yeah.
Thank you.
Good.
Thank you too.
Thank you. So it's time to move to the last part of this forum with our innovation and technology session, during which one of our members has the opportunity to introduce a new technology. There is a small change because Baptiste Laurent, founder and president of Vertuo, can't do the presentation today, and one of his colleagues, Stéphane, will do the presentation, and it is entitled Water Independent Greening Solutions for the City. So I think you are here, Stéphane. I saw you.
I see Stéphane. Yeah.
Yeah.
Good afternoon, everybody.
Hello.
Good afternoon.
I try to do my best. Okay. Derek from Paris. See.
Yeah.
So trees are quite happy in there. Okay, let's start. Thank you. Did you provide the presentation, or I do?
Please do, because I'm not sure we have the same, because we asked Baptiste to do a few changes. So you probably have the final version, you know.
Okay. Let me do this. Give me a second. Up, up. Could you see on the screen Vertuo, the first water sufficient green
Yes.
solution? Perfect.
Beautiful.
Thank you. So Vertuo is a French company based in France. Our aim and our mission is to bring back or taking care about the green, okay, in urban situation only. Okay, it's not for rural. It's really dedicated for cities. Okay, and you're quite central and mineral situation. So the idea of Vertuo is to bring back the green and take care about this green with the raining water. So we are conceptor and manufacturer. Everything is made in France. So imagine here, it's a cube, exactly as a Lego, a big Lego, 1 meter 20, okay? When you see the arrows is the soil level. So everything you could see after is behind. So it's under, exactly like an iceberg, okay? So the idea is to collect the raining water, as you see on your left. So half of the cube is dedicated for the water part, okay? Then we have a separator, okay? Before we integrate the plant and the soil, we apply different layers. We apply different layers of geotextile. The first geotextile is to stop the roots before the water, and the second geotextile apply a very natural aspect of capillarity. Pili. Okay, so then we take care about the soil and of course about the plants. So in fact, we provide a perfect environment for the plants and for the evolution of these plants. So the idea is to collect the main as we can, the water, so from the roof, obviously, okay, through the connection. This is with our outdoor solution. Of course, we could use and connect what is already existing in the cities, okay, all the swallow. We could collect directly from the roads. And of course, we could be, of course, display in a walking situation, cycling situation. There is you can notice a big advantage about the underground solution, as we could also irrigate, okay, what is close to our solution. So the grounds will be close, and as you see, as the trees, we could connect with a pipe on our cube, water cube, and then also irrigate the ground part. Here you have some different application, re-existing project. We have like 150 projects in France. So what you could see, mainly color, is the outdoor solution, and what you cannot see underground, so here above. So you will understand the fact we are using the raining water, creating the tank. So the tank you could see under is around 600 liters. So if the tank is full on beginning of June, so you could go through the summer very easily, as here you have between 60 to 99 days of autonomy without any human operation application, as this tank is really enough to provide enough water almost during 3 months. The big advantage also for the community, for the collectivity, the fact there is no need for operation and team to pass by every weeks or every 10 days. So this cost is avoided. So just need to go once or twice a year in order to just, you know, as a hairdresser for the plants, okay, in order to pruning and maybe take care about the plants. The idea, of course, is in order to also help you on the water efficiency. We could help you for sure about the plants, the choice of the plants, because depends on the location, mainly on the sun and also on the wind. So in order to apply the right and durable and resilient choice of plants for this your project. Of course, it's a wonderful friend and companion regarding the warm change, okay, climate change, and the warm zone, as we provide humidity almost by 99% around. So we could definitely decrease the sensation and the impact of the sun. So as I mentioned before, we are very dedicated for urban situation. So so here like a parking. So you're here in La Défense. Under you have a big parking, so you have a weight problem here. So we could install only 500 kilos per square meters. So the idea is definitely to stop the watering and do not use the common water only dedicated for us. So as I mentioned, the origin would be underground, and the oxygen is how you could consider this as a furniture and still connected. So for example, here we are close to prairies. The idea was to create a protected zone, you know, in order to avoid circulation and parking, especially for, you know, because you have here a ministry building and a different administration building in order to avoid, you know, the parking and any cars could go through. So we, you know, just normally you could see like a very big concrete cube, not very aesthetic and very cold. So we implement our solution, but in fact we reinforce the outdoor solution in order to make it more stronger and answer the norms about those circulation. So here you have the profile cut. So you could see the under system. All the cubes here they are dual. It means it's 1.20 meter and 2.40 meter. So we could do trio, quattro, or cinque anywhere. They are all connected together. So from up to down, because sometimes, you know, you have different collect points, stronger than some, because depends also on the relief and on the roads. So in order to create an homogeneous level, and I don't know if you could see, but at the end you have a big green park, and in fact all the additional water is going into this park. So we are not here to really to reuse the maximum as we can in order to reintegrate the raining water into the cities as much as we can. Exactly the same here. We collect the roof raining water. We collect the ground one. So you could notice here, you could see the small dark black line. So the water goes in. So in order to fill the tank. So here on the first level, you could see the Vertuo solution. On the second level, you could notice the trees. The trees are very independent, but they are fed with the pipe I mentioned before. Also here, the overwater is going into the land on the beginning and the end of the street. The same here. The idea was to create some cooling island. So you implement those islands in up front the street. There is the main wind. In order this wind, when it's running, okay, pass by, take the humidity in order to refresh the street. So when you see the bush here, in fact, there is this Vertuo solution under, but the trees are really independent also, and they are implemented in 2 by 2 meters areas in order for the roots to get enough space for their evolution. And also we are connected with the pipe. We could also go into the parking, exactly as here, see different situation. For all the road situation, parking situation, we could add an additional layer of geotextile. This geotextile treats chemical pollution and hydrocarbon. So they kept those pollution and clean by himself. It's auto system. Schools, we're doing a lot of schools for sure. With very easy for them to manage, and simply as that also, see, we could manage, like a downstairs office building, anything. We just implement our solution, in the water circuit. So the first one take the water from the roof and redistribute the other one. And you can make seating or not seating. If you want to do the round shape, no problem. Here, still connected for sure. Voila. And also different situation, parking, everything. And of course, we provide a mini solution for private people. Yeah, you could also connect it to the pipe. You have here like a 1 month autonomy. Voila.
Thank you,
You're
Stéphane. Yeah.
Welcome.
You're on mute, Moshi.
Don't be shy. Actually, we set up R&D center close to Paris since a year, and it's very helpful for us in order to test everything related to the water consumption, the soil, and the plants. So in fact, we make the choice about choose around 30 plants, and we push those plants into 2,100 water climates. As in fact, we are we've been chosen by Météo France 2 years ago also. So we use the data from Météo France in order also to apply all our survey to test and to manage and to control in order for us to help to choose, what is the best plant for which situation, and also how react the plant about the dry effect or over water effect. It's quite useful tools, but that's what we got here. If you have questions,
Bruno is asking, how do you control mosquitoes?
Oh no, what you see, the cubes or whatever, that they are all closed and hermetic, so there is no mosquitoes inside. In fact, the setter, the cube are totally hermetic. So there is no link with exterior. So Madame Mosquito cannot get in.
Okay. I have another question in the chat. What is the cost for a bush associated with a 600-liter tank?
The price of a cube of setter is 1,000 euro.
1,000 euro. Okay.
Of cube, 1 cube.
So you could consider with construction cost. I'm talking about French price. For simple situation, you could consider 1,000 to 1,300 euro without taxes per meter.
Okay.
Okay.
I have another question. Is there a monitoring solution for the town to see what is the level of each tank, the level of water? Yeah.
Yeah, of course. We could connect, no problem. With you know, with solar with the pipe. We could take care about the humidity level, water level, and also we could implement, you know, a transparent tube in order to visit and to see the roots development. We could do that also, no problem.
I have a quick, yeah.
Go ahead.
Yeah, I'm sorry, just Stefan. Thank you for this presentation. I saw
welcome.
already the solution, and maybe to relate it to the previous presentation. I don't know if you've been with us with the presentation of Professor Savvas. Is it irrigation, Vertuo? Is it part of the irrigation? Because I'm trying to fit it into the irrigation sector. Is it the irrigation solution? Is it the alternative for irrigation solution?
It's an
How do you see
alternative.
this?
It's an alternative since you could create urban greening display with using the raining water, but in fact, I don't know if you know the Stockholm Falls.
No.
Do you know the Stockholm Falls for the trees?
No.
Okay, it's close to our system. In fact, the Stockholm system, you implement the trees, and around, very close around, you make it empty in order when it's raining.
Yeah.
You could fill this empty space with the water. But in fact, the reserve, the quantity is very small, and disappear very, very quickly. So our idea is to create this tank, this temporal tank, for 2 or 3 months, and in order to redisplay the raining water among the display with the time being, in order to avoid this manual watering. In fact, in France, the name of this natural system is bocage. Bocage is from Normandy. It's in the countryside. You have a big hole. So when it's raining, this hole,
this field
water, and slowly with the time being, this hole feeds all around. That's why we take the name of this natural system, because the range name is bocage urbain, urban bocage.
I like it. Thank you.
The idea is really to maximize the raining water, to use it and try to reintegrate it as much as we can into the urban system, and even in the already existing soil. I don't know if you know, I mean, French, we are quite lucky. I don't know if it's efficient. We have the water agency. I don't know if you know that.
Yes, we know.
Okay, so this water agency is trying to promote and push all the collectivity to reintegrate
the water cycle
into the system, okay, in order to recreate the circuit. And they like us if we are not connecting into the water pipe, the water dedicated for the water circuit. When we reintegrate this in the ground, this is very much the idea.
Yeah, I think it's a complementary.
Yes,
I think it's a very
absolutely.
good complementary system in urban.
Now we've been working with 2 or 3 manufacturers in order. So I don't know if you heard about this. So we have this specific geotextile. This is not our development. This is a common development. So in order to keep the hydrocarbon pollution and to clean it.
We know many solutions based on the same concept to observe and to keep and to diffuse the water in a certain way that makes sense later on. It's not only the collection of the water.
I don't know if
we have 2 more questions in the chat. So do you have already some implementation in south of France or in Mediterranean countries?
Yes, we've been 2-3 installations in Monaco. We have 2 streets in Cannes, and this summer we're gonna have 2 schools in Cannes. We have a high school in Valoris, Collège Picasso, Saint-Laurent-du-Var, Toulon, Marseille, Banyuls. Yes, Marseille, oui, j'ai déjà dit. Yes, we start to be to Aix-en-Provence.
Other countries, Spain, Italy?
Yes, we are talking about project in Spain, Barcelona. We are talking about project with to Torino, Turin, and Rome, and also with Geneva, with the airport Geneva.
Okay.
We are, yeah.
Okay, and there is another question. What is the potential in terms of flood control with such system, and did you simulate it?
Yes, in fact, you have different approach when you have a project, or you have a water issue, or you have a climate issue in Mens. So we could complete this. We're using algorithm, and so we could definitely manage in order to define which is the strict minimum display you need to implement in order to answer the water quantity at the moment, but also with the Météo France perspective in 10, 20, 30 years. Do you mind if I share something very quick?
I think that we're just getting to the end of the session. So
I just like
maybe
to
just for 1 minute.
Just this.
Yeah.
In fact, we from Paris City, they ask us to create our system in existing solution. So we call this one the Orangeraie. I'm sure you already saw this one. It's a very classic one. You have in many parks and many Versailles or many parks, Les Tuileries. So in fact, we implement our system in this existing now. Okay. In order to, from aesthetic and also cost, because it is half cost. So in order to reintegrate, we could use a water reserve tank with our separators and of course the geotextile in order to. So most of the time, unfortunately, those are not very close to a collect point. So we add a pipe in order to fill it. So you need to come to fill the solution 3 or 4 times per year.
Yes.
Oh no, sorry. Voilà.
Bless you.
Thank you.
Super.
Merci.
Any more questions that we have from the audience? Fleur?
Yeah, I had one question about the pollution
Last one,
control.
please.
Yeah.
Okay.
About the pollution control.
Yeah. Again, with the
how do you control pollutions? Because when you have water which is coming from a street, obviously you will have hydrocarbons, carbons, and
geotextile. I mentioned twice. We add another layer, geotextile, specific geotextile. We kept the hydrocarbon, and it's based on a, je sais pas le nom, an enzyme. It's based on enzyme. So the geotextile keep clean the water of the hydrocarbon, and the enzyme clean the geotextile. So it's you have 3 manufacturers in France. Dupont, you have one in Saint-Étienne also, and one in Normandy. It's apparently it's very efficient. Many parking are also they using many parking manufacturer using this solution. I could share with you the technical aspect if you like. No problem. It's Amter. Our main provider is Amter. AMTER. Everything is from France.
Okay.
Good. Anything else, Fleur? Well, in the chat now.
No, nothing
Okay.
more. Yeah.
All right. Just a second, Stefan. Let us just say a proper au revoir. I don't know what the temperature is now in Paris, but it seems to be that
Very good.
outside, right?
It's
good today.
better. Yeah, it's
See?
better.
This is my
Okay.
personal, huh? This is
Yeah,
not
yeah.
Vertuo.
Okay, goody. So just a few closing remarks for the end of the session of today's session. We're reaching the end, and let me say just a few words. First of all, thank you very much, Stefan and Professor Dimitrios. I think
you
that
very
it
much.
was very interesting to find the similarities between the two presentations. Because I think that it always reminded us that we're coming from completely different aspects of the irrigation, but the irrigation is evolving, and irrigation is no longer just about delivering water to crops or traditional sense that we used to do. It is about precision. It is about using an alternative method. It is about urban resilience. It's about climate adaptation. There are so many aspects that we can match, and we can see the similarities between the two quite different presentations today. So I'd like to thank you very much for these two presentations. Very, very interesting. I'd like also to thank Daria and Fleur and Bruno for helping organizing today's forum. Next round will be in a few months. Thank you all the participants that are still with us now, the new members who came today, the not yet members who joined us today. I think that these are exactly the discussions that we like to continue to host. So thank you very much. I wish you all a wonderful afternoon, cool afternoon, if I may say. Looking forward to seeing you in one of the next events of the EIA. Take care, everyone. Goodbye.
Thank you.
Bye-bye.
Bye-bye.
I just add the link for the geotextile anti-pollution from Amter. Okay.
Okay, thank you.
Thank
It will be in there.
Bye-bye.
Thank you very much.
Thank you. Bye-bye, everyone.
Bye-bye.
Bye bye.
Thank you. Bye bye.